Alright guys, I'm trying to help you guys over this hump and looking at schematics. So we're looking at the right here, the PDF. There's the series circuit. And you see here I found this online, they call it schematic capture software, and I guess meaning because like you draw it and then it turns it into what's called a netlist, which don't sweat. In the sense, netlist goes into another program they use to make printed circuit boards. But we're just interested in drawing schematics quickly and easily. And so I found this thing. It's free. It's online. Tinkercad doesn't do such a great job with making schematics. I was just playing around and see what it was like. So I'm going to just save this one here. Let's see what it does. You must log into your DigiKey account. Okay, so I actually have one. And so I will log in. And so this is a parallel. Oops, resistors. Oh, I don't know, I'll call it 1 for now. So it's not like Tinkercad where it automatically saves. Okay, so you'll notice here on the left there's a toolbox. Oh, schematic symbols or something we need. So let's see, we need resistors, which are a passive element. Yep, there we go, resistor. So let's pick one that we commonly use. And I wonder if, okay, so let's see, we want to rotate that. What happens if I right mouse click? Nothing. And so let's see, I did not see how to rotate it. Let's try clicking the R button. Yep. So I just I just hit the R button on my let's see if I can do it now. Yeah, I hit the R button and it rotates. Yeah, the only thing that's a little drag, I have to go over here each time and click. Most programs, what happens is you just work and you keep clicking and you get more and more of them, and then you tell it to stop. But when it's web-based, it has to be able to do everything. Okay, and so I need a battery. So that's a source. And voltage source, this is multiple cells. Good enough. It looks very much like things we commonly look at. There it is. Okay, so let's wire this up. Notice how it highlights, and then we can go down the line, and then let's see, click, and then there you go. So now there's our basic series circuit. And so instead of having like a dead end here, we now have, oh, I can't move that because okay, I wonder how you can add a node to it. No, I would have liked to have had a little space there, so let's try that. We click, there we go, click, and there it is. Alright, nice. So now we show the obvious return path instead of what we see here, this kind of open-ended circuit. Now let's see, can we add some information to this? Catalog, assign, where can we put a value? Guess I go, oh yeah, so now that I've got it selected, all of a sudden the right mouse key works. So it doesn't seem like I can set. I'm going to pause the recording. Hold on. Well, you won't notice any difference. Alright, I forgot about this toolbar at the side here. So now we have 110, and we have R2, and that's 220, and 330. And there it is. Okay. So we have R1, R2, and so this, let's see, export. What is this now? Document. Oh, interesting. Or we can simply print it. This preview. Where does it go from here? Proceed. What's the cat? Dog's back there harassing the cat. Okay, so thing is, this is a preview, but then how does it print? I don't get it. There's no print dialog. Well, that's another hurdle to cross, but I suppose export it to either a PDF, current page, active area, yep, paper size. Let's try that. Let's see what it looks like. The idea would be that we'd be able to make a PDF and print it, because it didn't seem viable to just simply print it directly. We'll have to play with that some more. And let's see, series, just for now, let's take a look at what we get. It may just automatically show it to us, I don't know. Let's see, series.pdf. Oh, there you go, pretty. And so, it's limited to a certain size. What the hell is he chewing on? No, I think that's okay. But that's something to explore another time. Now, at the same time, here it is in Tinkercad. And the point is that a schematic is really useful to sort of trace things out. And so if guess we need to make two windows here. Oops, what happened to it? And I have to make sure I keep it on the screen. There we go. So now we see we leave the power supply. In this case, it goes to these rails. And if it's really getting confusing, there's an easy fix here. You can get rid of these two. And now let's make this circuit in its very simplest form. And so we'll say that we're going to leave the power supply. And we're going to right away just go right into the resistor. Then we'll make us another one here. And we'll take this to the last resistor and we'll make it black so it's more obvious. Okay, so now you see I leave the power supply, I go into R1, see how they're all connected together. And let's make it a little bigger. Then I leave R1, I go to the jumper here, and now I go to R2. And then I leave R2, cross the jumper to R3, and back to the power supply. And that's what I have in my schematic right here. So exactly matching at the moment. And one good indication, at least we see some current flow. Okay, so now remember the mantra current through, voltage across. So if I want to measure current, let's see, we want test equipment. And I want, let's see, it's fancy. I want a horizontal ammeter. So if you want, we can get one with, has a plus minus to it. It's not critical. So now if we want to measure the current from R1 going to R2, what we have to do is we have to actually break the circuit. And then we put in our ammeter. And if you like, we can make it sort of resemble Tinkercad because we'll have it over here. So now we can go up. What is this dog doing? He's restless for some reason. And then here. And now we've broken the, so did I get it? Yeah, it looks like it. Okay. Oops. Let's bring this over a bit so we can see it. Yeah. So now we've added in an ammeter. And so what we did there is we broke this, we took out that line, brought ourselves an ammeter over. And notice the plus and minus are reversed here. It doesn't really matter because it only matters really if you have a needle type or analog ammeter. But you can sort of help yourself visualize. So when it's going to be, the flow is going to be out, so the flow is going to go up to it. So you could use red there. Or sometimes I use like a variation of a color that's close to red. And now I go back to R2. And so we start the simulation and we notice, look at that. The two currents are the same. Now again, the big deal is that when you do current measurement, current through, you have to break the circuit. Now, the next step is voltage. Voltage across, okay. Voltmeter. So let's bring a voltmeter on. Voltmeters are always much easier because you don't have to break the circuit. We can just splice it in there. And splice it in there. So you see the voltmeter and R1 are in parallel. So, and also as far as tracing, I've got to say it again, out of the power supply through R1, out of R1, up to the ammeter, back to R2, and so on. So I've got a voltmeter here. So let's connect it in. So then we got, that's a little inconvenient with these guys because of the way, let's see, yeah, I have to hit, I want to get there, so that's one end of the resistor, and now let's get another color. The colors are good as when this thing starts getting complicated. It's much easier to troubleshoot an issue. And so now, yep, that's connected and that's connected. Start the simulation. And yeah, it's negative, but you see, oh gosh, see I have the current comes out here and it's going into the black terminal, so the current needed to make a measurement is going in. If it goes in the black terminal, you're going to get negative reading, just like it shows up here. It's no big deal. You just got to keep track of it. Okay. So, anyways, as I was saying, it's important to have a good schematic, and I think that these schematics that are in the lab manual are a little tough to deal with, and if you know, most of you guys haven't had a chance to do any wiring at all, and now you're jumping right in. And so this simulation, it's pretty easy to get up and running. And remember, again, use the schematic symbols. Where did it go? All right, so that was how it started. Schematic symbols, and it's sometimes little, just trying to figure out, but it's little what it's, where to find the part you need. But source is pretty easy. The other one though that was hard, passives. Capacitors, inductors, and resistors are passive. In fact, you learned in Physics 2200 that capacitors and inductors are reactives, actually. So when they mean in the sense passive and active, as in like transistors. Transistors are active because they can amplify. So obviously there's no standard nomenclature. All right, let's see how this helps.